This is number 7 on the EOC review. On number 7, it says, which algebraic expression represents the area of the shaded region in the figure below? So we're just trying to find this whole shaded section, which obviously means this unshaded section we're going to eventually have to remove. When you're doing area, you want to be able to find area of each part. They were kind enough to put this little dotted line here, which shows me that they can break this into 2 separate rectangles. So I can find essentially the area of this little part here, because remember it would be length times width. So let's go ahead and find the area for the small one so far. I have 2x minus 1 times x squared minus 3. Now what this is a binomial times a binomial, so you want to FOIL. So when you FOIL, you want to do your first terms. 2x times x squared would be 2x cubed. Then you want to do your outside terms. 2x times negative 3 would be negative 6x. You want to do your inside terms. Negative 1 times x squared would be like negative x squared. And then you want to do your last terms. Negative 1 times negative 3 would be positive 3. Now notice again, I've got my half crescent moon, so I know that I've got all the terms, and so now I just need to clean this up. When we clean it up, we like to put it in descending order because it keeps us organized. So the highest exponent I see here is 3, so my first term will be 2x cubed. The next highest exponent I see is this 2, so I need to bring that negative with it, the negative x squared. The next highest exponent I see is a 1. There's an implied 1 here, so I'm going to bring down that negative 6x. And then the last one will be my constant. The constant always goes on the end when you're putting it in descending order, so plus 3. That right there is this section, okay? So this section I'm going to go ahead and label as 2x cubed minus x squared minus 6x plus 3. Let's see if we can find the area of this shaded region. I do have the length, but what I don't have is this width. However, what I want to show you is that they told me what the whole side here is. Now this whole side is 10x plus 9, and this little section, which matches this section here, is 2x minus 1. If I take this whole side and subtract off this section, what's left will give me my width of this rectangle. So next thing that I want to do is take this 10x plus 9, and I want to subtract this one here, so that's going to be this side right here, so I can see what's left. So minus this 2x minus 1. Notice the use of parentheses. That way, we can be very careful. Here I've got 10x plus 9, and then we're going to subtract, and I put it there in parentheses so I can distribute. So here I've got 10x plus 9. There was no coefficient out front of it, so I can drop the parentheses, but we will distribute this negative. So negative 2x, negative times a negative is a positive. Now let's combine our like terms. 10x minus 2x would be 8x. 9 plus 1 would be 10. So that means that this little section right here is going to be 8x plus 10. Now I've got my length and my width. So what I need to do is now multiply these two together. This is going to be a much bigger problem. I have 8x plus 10 times 2x squared plus x plus 12. The reason this is going to be a bigger problem here is now I have a binomial times a trinomial. When you're multiplying these together, you need to split the first polynomial. In this case, we're going to split the binomial. So 8x, and then we're going to put a big space and plus 10. And then behind each of these, essentially, we're going to distribute the 8x to every term in this trinomial, and then we're going to distribute the 10 to every term in this trinomial. So I'm going to rewrite this trinomial here. I forgot the 2. 2x squared plus x plus 12, close the parenthesis, and do it again. 2x squared plus x plus 12. We've got to distribute each of these terms in the binomial to every term in my trinomial. Now, 8 times 2 is 16. X times x squared is x cubed. 8, and notice again what I'm doing is I'm just distributing to every piece. 8 times 1 is 8. X times x is x squared. Then here I've got it again. 8 times 12 is 96, and then I have that with an x. Now the next thing I'm going to do, same process, but we're going to do it with the 10, and we're going to distribute the 10 to each of these pieces. 10 times 2 is 20 with the x squared. The next one, 10 times x is 10x. And then here I have 10 times 12, which is 120. So now what I'm going to do is clean this up by adding my like terms. Do I see anything else with an x cubed? No. So that would be 16x cubed, and because there's so much here, I'm going to go ahead and cross that out so I can keep organized. Let's look for the x squareds. Here I have 8x squared and I have 20x squared. So that is going to give me a total of 28x squared, because remember, we keep the base but just add the coefficients. That's those two. Next, I'm going to see, oh, I've got an x here and an x here. Those are my like terms. 96 plus 10 is 106 with the x. So that's that. And then I have plus 120. That's this section here. Now, I'm not going to rewrite this big section here, but I do know that this is going to be my big rectangle. Now, the last thing I need to do is I need to figure out what the area of this guy is, because eventually I'm going to have to subtract him off. So let's go ahead and find the area of this last piece. What I see is I have a length and a width of x and 3x minus 2. So all I have to do is just distribute this to both pieces, and what that gives me is 3x squared minus 2x. So that's going to be the area of this little piece right there. So this is the blank rectangle. Now the last step is to put everything together. So first thing I want to do is I want to go ahead and take this big rectangle and this rectangle here and add it together to find the total shaded region without taking this part off. So I'm going to take this and I'm going to add it to this piece up here, and I'm going to line up my numbers. So here I've got 2x cubed. I'm going to put that with the x cubed. So we're just adding. Then I've got negative x squared. Then I've got negative 6x, and then I have 3. So what I'm going to do is just add this all together. So 16, and actually I'm going to start over here, but it doesn't really matter. Usually we start this way. So we have 120 plus 3 would be 123. Then this is 106 minus 6, which would be 100x. This is 28x squared minus x squared, which would be 27x squared. And then here I've got 16x cubed plus 2x cubed, which would be 18x cubed. Now I've got all of that, but don't forget we got to subtract off this one rectangle. So now we're going to subtract. Now, if I'm going to subtract, I'm going to show you this just so that you don't make that common mistake that students make. I'm going to take this polynomial and subtract this one. I'm running out of space, so I'm going to do it up here. But it's this polynomial of 18x cubed plus 27x squared plus 100x plus 123. And I'm going to subtract from that this blank rectangle, 3x squared minus 2x. That reminds me that I'm going to have to distribute this negative to both pieces. Nothing's outside here. We can drop off the parentheses. 18x cubed plus 27x squared plus 100x plus 123. Then let's distribute minus 3x squared plus 2x. Finally, we combine like terms. So I have 18x cubed. That's done. Now let's look for my x squareds. Here I have 27 minus 3, which would be 24x squared. Those are done. Here I have 100x plus 2x, which would be 102x. Those are done. Now I've got plus 123, which when you look at this final answer, a lot of work involved, gets me my answer choice A.